Right. So yeah, I'm going to be talking to you today about contracts in the wild, a study of Java programs. Okay, this is work that I've done with Dietrich, Kamil, who's in the audience as well, and Premek, Brada, and both of those are at Pilsen. And Jens is a Kiwi, well, sort of Kiwi, in Massey. Cool. All right. I guess I should say this is a 20-minute presentation, so there are lots of details in this paper, and I can't cover all of them in the presentation. I'm just going to try and give you an overview. Dig into the paper. Sorry for more details. Okay. So in researching this paper, I came across this quote, and I should thank Clark and Rosenblum for this quote because I haven't seen the original, an original copy of the paper itself. They did a very nice historical perspective on runtime assertion checking, which is definitely worth a read. But it is a quote by Alan Turing. Whoa, oh my God. I just quoted Alan Turing. It's amazing. I was like, I'm not worthy, right? And what did he say? He said, okay, in order that the man who checks may not have too difficult a task, the programmer should make a number of definite assertions which can be checked individually and from which the correctness of the whole program easily follows, okay? 1949. Now, I don't know for sure, but this will certainly be one of the first references to assertions in the context of program correctness, right? So, when I found this quote, it was actually kind of amazing for me because it's really saying, runtime, well, I guess specifications of programs, they go back really to the dawn of computer science. That's the takeaway for me, that they have been there from the beginning. And this is an idea that has been around for a long time. So how are we going with that idea, right? That is always the question that I am interested in. Those that know me will know that. And of course, there has been a lot of work in the intervening, decades, or not quite a century, okay, whatever it is, 60 years or something, looking at the use of specifications, contracts, okay, on programs. And there's a whole bunch of crazy people, totally crazy people who like to, try and actually formally check that these preconditions and the postconditions are adhered to by their functions. Dave, you're one of those crazy people. True. Thanks, Dave. Of course, yeah. Don't want to forget that. I'm not going to mention the W word in this talk. That is part of the agreement. But there are a bunch of really cool tools such as Daphne and SpecSharp and loads and loads of others, Idris, Agda, etc., that take a kind of a formal checking approach to making sure that our precondition, our specifications are satisfied, and that's cool. Okay, it's not what we're going to focus on in this talk though, but we are interested in specifications, and we found this conjecture, which is by Arnott and Bertram Meyer, and I have to say Bertram Meyer in particular has done a lot of interesting work in actually studying the use of contracts in practice, and I really found his stuff quite interesting in this space. They had this conjecture. It is this question that leads to the closet contract conjecture. Are the contracts of Eiffel libraries a figment of the Eiffel programmer's obsession with this mechanism, or are they present anyway, hidden in non-Eiffel libraries as well? Now, I think as programmers, I'm a programmer, we probably suspect that yes. Okay, in languages which don't support, first-class preconditions, postconditions, and invariants, and so on and so forth, yes, in those languages, programmers will still try to write their contracts, right, without question. What they will do is they will make use, and this is really what the conjecture is about, they will make use of whatever means they have available to them to express those contracts, right? For example, they will use exceptions, they will use non-null annotations, they will use methods with appropriate names like check precondition, and so on, right? And this is the closet contract conjecture, and it's nice because it's a kind of conjecture. We can try to see if there's any truth to this conjecture, right? That's what it's about, and that's really what our work is about. It's trying to dig into this conjecture and seeing what we can find. And it's not easy, okay? Let's be clear. This is not an easy thing to look into. There's no question about that. Okay, so a quick overview of what we actually did. It's a fairly straightforward approach to empirical analysis of software. We downloaded a whole bunch of popular software programs from Maven Central, big jar files. We downloaded all the versions for each one. Maven Central is really useful because it gives us all that versioning information very simply in the pom.xml file. We downloaded them all. We filtered out some for various reasons. We'll come back to that. And we then did a simple static analysis to try and look for instances of hidden contracts, right? And we'll come back to exactly what that means in a moment. And then once we've done that, we just aggregated the data and did some analysis, and I'm going to report the results of that today. I suppose I should have had another thing that said a yellow arrow to the right after data analysis, present paper, something like that. I don't know. Cool. So that's the rough idea. So some of the research questions that we sort of really tackled in this paper. Probably the first one, the main one, I guess, is which language features are actually used in practice to represent contracts in real-world programs? Second one, how does the use of contracts change throughout the evolution of a program? And what we mean here is, you know, if we have a program that has some contracts in it, are we expecting that the prevalence of contracts is going to go down as the size of that program increases? Or perhaps the opposite? What happens? Next up, number 3, are contracts used correctly in the context of program evolution in real-world programs? Okay, so if we're thinking about versions, and this is where Maven is really helpful because it gives us versioning information, if we look between 2 versions, you know, how do the contracts change on the same method? What happens, right? Because there are some things that will be okay and some things that might not be okay, right? Can we see anything there? And finally, we try to look at the Liskov substitution principle, essentially, which is basically looking at the use of contracts in a subtyping context. You know, are contracts used safely in the context of subtyping? Cool. Okay, so contract patterns. So what we basically wanted to do was to cast a wide net in terms of what is a contract, right? And, you know, we could have casted a wider net than we did, okay, to be honest. But we did as, you know, we cast as wide as we could, and we came up with a whole bunch of different categories. And so we've got, obviously, runtime exceptions. We call them conditional runtime exceptions, which basically says, look, you know, if we've got in our method, if some condition, and we throw an exception, like an illegal argument exception, you know, then that is a contract element, right? Part of a precondition, not necessarily the whole precondition, but part of a precondition for our method. And we picked a small set of highly used runtime exceptions here. So, for example, null pointer exception, illegal state exception, I think index out of bounds exception was one of them as well. And these are the exceptions we look for. We didn't look for general exceptions like, I don't know, SQL, MySQL exception or something like that. No, we only looked for predefined set of exceptions that we knew something about. Moving on, we've got unconditional runtime exceptions, and this is basically, there was only, as far as I'm aware, only one case of this, which is looking for throw unsupported operation exception. And we treat this as being the sort of strongest possible precondition, right? So if we have a method that says throw unsupported operation exception, that is like saying in a language like Daphne, you know, requires false, as in you cannot call this method, right? Okay. We also looked at contract APIs. Now, it turns out there are a whole bunch of libraries out there, in particular Google Guava, Apache Commons Validate, and some others that I can't remember specifically. And what they do is they provide classes which are specifically for the use of checking contracts. Okay, and so this one here that I've got, preconditions check state. Okay, that's from the Google Guava, and there's a class called preconditions, and it's got a method check state, and it is for, guess what? Checking preconditions, right? So, okay, if we can find occurrences of that. Yeah, that's interesting, okay? We've got Java assertions, obviously, a very common form of contract checking. The essential problem with Java assertions, it's difficult to classify them, and so we had to leave them unclassified in our study, but we can still look at how much they're actually being used. And finally, another kind of big area of contract elements that we could find were annotations, and there are a whole bunch of you know, specifications. So, for example, JSR 303 and 349 are to do with the Java beans specification, in particular for validating beans. And then we've got like non-null annotations and find bugs. We put JML in the list there, so we actually look for instances of JML, you know, preconditions and postconditions, and there's Lombok and some other things. Now, the annotations that we picked out were annotations that specifically we understood what they meant and that they were relevant to, you know, contract checking, not just arbitrary assertions like, I don't know, test or something like that in JUnit. No, we didn't look at anything like that. We picked a specific set of annotations that made sense in this context. All right. Yeah, cool. Okay, and so then we basically classified them, and so what we did is we classified runtime exceptions all as preconditions, okay? We classified contract API as preconditions, and the reason we did that was simply that, like in my example from before, all of the contract APIs that we looked for only allowed you to check for preconditions, right? That's why, otherwise we would have done postconditions as well. We had assertions as unclassified because we couldn't tell really if they were being used to check preconditions like loop invariant or postconditions and so on and so forth. And then we classified annotations based on their position. So if it's a parameter annotation, like at non-null on a parameter, then it's a precondition. If it's at non-null in the method position, then we said it was a postcondition. All right, and finally, yeah, we have class invariants as well. So if we had annotations on fields and classes, like at non-null on a field, okay, that one doesn't make sense in the context of a class, but then we would call it a class invariant. And that was our classification. For the analysis, we basically made use of Java Parser. The Java Parser library is totally awesome for this kind of stuff. If you haven't used it, you should be using it. It is so easy. And what it gives us an AST for Java source code. It's pretty straightforward. And then we just go through and we visit nodes and we attempt to match our patterns. And in this case, you know, in this particular one I'm looking for here, we're looking for the pattern if some condition, throw new exception. And we will check the exception, presumably in the body here, to make sure it's one of the ones that we're looking for. And that would be a match of you know, a contract element. And we can see immediately that our analysis is conservative, right? We are not, you know, I can write a semantically equivalent code to that pattern there, okay, which this thing will not find. You know, I could just have, I mean, it will look for the case where we have a block, so I use curly braces, but I could have some if condition, curly braces, x equals x, throw new exception, and I don't know if we're actually going to find it in this case, in that one. Actually, we probably will do, in fact. What would be good? We could have maybe multiply nested ifs or something like that, or we could have a for loop that didn't return or something like that, and it wouldn't find those. So we're not catching everything we possibly can catch, but we're catching all of the really obvious stuff. Right? That's what we're going for, the low-hanging fruits. I'm trying to give us a kind of conservative approximation. Yeah, the code, by the way, is available, and we have an artifact as well, I should point out. Cool. Okay, so for the corpus, we looked at the top 200 artifacts listed by popularity on Maven Central, basically. And you can actually go, if you go to that link, you can see it lists, it's quite cool, it lists all the projects by popularity. And so then we just downloaded all 200 artifacts. We stripped out projects that didn't have any Java source code in them, okay? So there are some projects that are just Scala projects, okay? So the source code is in Scala. Yeah, okay, we're not going to analyze Scala, we just chuck those ones out. And then we pulled all of the versions as well for each artifact. And after that, we had about 176 projects comprising, you know, roughly 7,000 versions and about 4.6 gigs of data. So that's a reasonable sort of, what's the right word, corpus to look over. There are certainly lots of interesting questions about the impact of our choice for the corpus, for sure, but we had to choose something, and Maven turns out to be really useful in this study because it gives us the versioning information, it gives us the dependency information right there in the pom.xml file. So, you know, I think it was sensible. Cool, okay, so I'm going to present data. I've got about 6.5 minutes left. Okay, so looking at our research question 1, which language features were actually used for contracts? Okay, so we'll just ignore the bottom one down here to start with. I've classified them by category on the left-hand side, and we've sort of broken them down. We've got contract elements that we found across all versions, and then we've got contract elements that we found across the latest version that we downloaded, just to try and give a feel for, you know, how much we've actually have in one snapshot of time, if you like. And then we've got the number of programs that have at least one contract element in them. And so there are a couple of takeaways immediately from this. The first takeaway is that if we look at the programs, actually we're finding quite a lot of programs that are using runtime exceptions. Okay, it's not completely surprising, but we're not finding heaps of programs that are doing other things. Assertions would be the other category that is somewhat large, but you know, we might have expected it to be a little bit bigger. And there's some interesting questions why that is. And we certainly did find, you know, if we look in the runtime exceptions, particularly for the conditional runtime exceptions, we did find a lot of instances of our pattern. So certainly there are a lot of occurrences, and we're going to come back to that in a moment, and because we dug into that a little. If we look down now at the classification. So what I've done now is based on our categorization, I've categorized them into the precondition, postcondition, class variant, and so on and so on. What we notice is that we're actually finding the vast majority of preconditions, and that is partly an artifact of our analysis. Well, partly an artifact of our analysis, in that if you look at the categories, most of them are preconditions. There's only one category that's postconditions, but it also reflects something about, or at least we believe it reflects something about programmers' sort of mindset, and that they have quite a defensive mindset. So, there's no class for checking postconditions in Google Guava, right? Which is odd. Basically, what it's saying is people are only really interested in checking preconditions, and that's because potentially, as a library designer, you want to make sure that stuff coming into your library function, the preconditions make sense, so that you don't get the blame. And you don't really care about the postconditions. Someone else is going to use that. It's a theory. Cool. Okay, so we dug into the data a little bit. So, like I said on this one, yeah, we did find a lot of constructs for runtime exceptions. And we dug into that a little bit. The thing that we found, I suppose in a way that's a little bit disappointing, maybe even surprising might be the right word actually, is that we had, a small number of programs account for a lot of those constructs that we found, right? And that actually, if you look at it up here, so we've got the, this is the number, the count by benchmark. I think it's just across the latest version. And what we're seeing is that, yeah, we've got a lot in OpenJDK, but even after 5 things, we're already getting down quite quickly, and that just tails off really, really quickly. And we looked at the Gini coefficient here, which is basically a measure of inequality, where 1.0 means we've got one thing that has everything, and all the other things have nothing. And we found it's 0.74, which is quite high, which means there's quite a large inequality within our data set. And it's a bit surprising that, I think, personally. But we did find some other interesting things. So we found that there weren't that many programs that used 0 contract types, which perhaps is surprising given how it looks. And we found that only some programs use 1 contract type, in this case 18%, that's 32 over 176 programs. And in fact, most of our programs use multiple contract types, which is perhaps surprising. That they're using, let's say, maybe runtime exceptions and annotations, something like that. And it's odd. I guess what's odd is that they're using them, but they're not using them that much, right? Which is strange, but okay. Cool. Alrighty, and so we carried on. We looked at the second research question was basically, well, how do the use of contracts change in time across our data set? And so what we did here is we wanted to measure the proportion of contracts in a benchmark from the very first version that we saw of it to the last version. And proportion here just means we took the number of contract elements and we divided it by the number of methods, right? And so what that would mean is if the number of contract elements stayed the same, but you added more methods to your program as the versions increase, then you'd expect to see the proportion going down. But actually what we found was the proportion is staying pretty level. And what that's basically telling us is that for projects that are using contracts, they continue using them. And not only do they just continue using them, but if they add more methods, they're going to continue adding contracts. So basically, those projects that buy into using contracts, they buy into them completely. That's a rough approximation of what it means, I guess. Cool. Now, are contracts used correctly in terms of evolution? So what we're interested in here is looking for what we might think of as contract violations. So if I have one version, let's say a method in one version and a method in another version, and there's a change in the precondition, then there's 2 things that can happen. Either the precondition can get strengthened, which is not safe, right? Because if the precondition gets strengthened between the versions, then someone using that version, and then they update to use the new version, they might have been passing in, let's say it goes from allowing null to not allowing null. Well, here they pass in null, they update the version, and now you have a problem, right? So we were looking for this, and the same thing for postconditions, except it goes the other way, where weakening is a problem rather than strengthening. And yeah, we did find some occurrences between versions here where actually we had some problems. So in this case, we're actually finding a reasonable number of instances between versions that seem to be suggesting actual sort of contract violations. We didn't dig into the semantic version in the sense of to look to see whether or not every time it happened it was a major version change. In fact, we know that it wasn't because we found examples where it was a minor version change that had a strengthening of a precondition. And so it would be interesting to sort of dig into that a little bit more. Cool, all right, okay, so that is technically my 20 minutes up. I'll just quickly flick through this, I'm almost done, all right? Cool, okay, 3 more minutes. He's given me 3 more minutes, okay, cool, that's great, okay. Fine for me. So then the last one is, so we looked at the evolution between versions. We also looked at how contracts are used in the context of inheritance, right? Subtyping, right? So not just class inheritance, but also interfaces and so on. And in particular, you know, if one class is a superclass of another, the question is, if we've got the same method, how are the preconditions between those classes? You know, so we could have a method in the superclass which, let's say, allows null, and then we could have a method, the same method in the subclass, which has a non-null annotation, right? And that would be a problem, because the superclass is basically saying, yeah, you can pass null into me, that's no problem, and the subclass is saying, no, don't pass null, that is a problem, okay? So we're really looking for those kinds of violations, and here we're basically saying, if the precondition is weaker, what this means is it's going weaker between the superclass and the subclass, and if it's stronger, then it's stronger between the superclass and the subclass, right? So stronger is the kind of violation, and weaker is okay, that's actually fine. And actually, we did find some actual genuine instances here where we are seeing some violations in subclass, you know, in the inheritance hierarchies of the projects we looked at. And we do have some concrete examples that we put into the paper if you want to have a look at them. Yeah. Cool. I guess, yeah, that's what I'm going to say. So that's pretty much it from me. So we had a look at this closet contract conjecture, which I think is a really interesting conjecture. You know, I can't possibly say that we have conclusively, you know, answered the conjecture, okay? It's kind of hard to do that. But we've certainly had a pretty good look at it, and we didn't find much evidence, really, that the closet contract conjecture holds. That is, yeah, we did find some contracts, but considering how many programs we looked at, we didn't find that much, realistically. But we did find some other interesting observations. You know, projects that do use contracts will continue to do so, and they will expand their use as the program increases. We did find some absolutely incorrect usages of contracts in the context of evolution and inheritance. And that's all from me. Thank you very much.
Thank you, David. Very nice study. A question about the preconditions that are getting stronger when you inherit. From your, maybe this is more of a qualitative observation, but do you have evidence that these are cases where the subclass is not really a subtype in terms of contract checking? Or is it a case where, I mean, I could imagine that could it be that the superclass has no precondition, or that it's just incompletely documented, and so it looks like it's being strengthened, but... Okay, so I think the issue of people adding contract elements onto methods is, you know, in terms of, yeah, the contract was implicitly there, but we forgot to have the annotation or whatever it was, and so we put it in. Yeah, that's definitely you know, a limitation in the sense of we didn't look for the implicit contracts and check if the annotations were there or not. So yeah, I think that is definitely a limitation for sure. And you did count those as strengthened, even if the... Yeah, because we had no way to tell if it was implicit. You know, like a non-null is a classic. If you dereference it within the thing, then it's there, but it's only if you wrote it that we really looked for it. Yeah, that's right, yeah. And this is just one example that we found in practice. And basically this thing is saying, if you pass it in a string, then we're okay. And then it's adding, in the subclass, this is a subclass, then it's adding this stronger assertion. And the has text is actually checking for detailed things like spacing and paragraphs and stuff. So it's definitely a stronger postcondition, precondition, sorry. So in this case, I think it is a genuine attempt to be a subtype. Yeah, we could only sample, so we couldn't look in detail at all the cases to really get a feel for that. It would be really interesting to do that, yeah.
You mentioned that in some cases you were surprised to find multiple different mechanisms in one project for encoding contracts. Did you do any correlation between the number of programmers who'd worked on the project? I mean, I can imagine that one guy likes to use this precondition package and another one likes to use assertions.
Yeah. Okay, so the answer is no, we didn't do that correlation. I think that makes total sense. That would be fantastic future work. Yeah, I agree, definitely.
Did you understand this, Andrew? Right. So we found one case, or sorry, two cases where entire projects switched from one mechanism to represent contracts to another one. They basically introduced their own contract API. So some of those things really seem to happen project-wide, not on the level of individual programmers.
My question is, do you have information about private versus public code and usage of contracts there?
So we didn't divide it up by public or private, no. So again, I think that would be interesting. We might expect to see less annotations on private methods, and I think that would be that would be a suitable hypothesis. We didn't test for that.
So did you check only public, or you checked?
We checked only public. Yeah, that's right.
Okay, so because my belief is that you get much more assertions in private code because they are used for debugging and are usually removed from the release version of code, like this assert would be usually removed. So people tend to use assert in your private code and runtime exceptions in public code because it's really important not to leak the bad.
I certainly think that there is a potential influence there in terms of exactly how we checked it, yeah. I'm not sure I would personally expect to see more assertions in private methods versus in public methods, but maybe certainly that is something that could be looked at. I mean,
it's runtime overhead if you use runtime exceptions in private.
But private methods are still going to be called from public methods, right? I mean, that's sort of, I don't know. I think it's a fair thing that we could look for sure. Yeah.
Okay, thanks.
So I think it's tempting to try to second guess what's going on when programmers are using these assertions, these different kinds of contracts. So if they have lots of preconditions and no postconditions, this makes a lot of sense because preconditions are associated with complex global properties, and the postconditions are much more about local reasoning. But when you have the preconditions and you don't have the postconditions, maybe you could say that a good theory about the programmers is that they are not using this for reasoning about programs because they don't tie the knot. They don't take the step that is associated with reasoning. They're taking a step that's much more associated with blaming the caller.
Yeah. So I think it's an interesting point there, thinking about how they're actually using them and the observation that they're not using postconditions much means they're not necessarily, for me, I would be like, yeah, of course I want to write but why would I not write my postconditions? It doesn't make sense that I wouldn't do that, right? So, yeah, I kind of agree with that. I think, the only thing I think I can say here is that there have been some studies done on corpuses, sort of static analysis done on corpuses which have contracts, in particular Eiffel corpuses by Bertram Meyer and so on. And when you look across these studies, you find sort of two different results. And it's not clear which is the right one, right? And the two different results are, one result is there are normally more preconditions than postconditions. And the other result is normally they are about the same. And reading between the lines, I think you have to, because there's a whole bunch of studies and they either fall into one of these two categories. Reading between the lines, I think what you find is when it's formally verified, you tend to be in they're kind of about the same. And when it's not formally verified and it's only runtime checking, it tends to be in the more postcondition category. But that is wild speculation. Okay, cool. Thanks, folks.